On my planet, we use regression models and integrals to find the volume of materials needed to build a spaceship. Thus, in order to find the volumes of the parts we need to build my spaceship, we need to know how to find the volumes of shapes found by rotating disks. In standard geometry, we learned that in order to find the volume of a certain solid, one must take the area of the face of that solid and multiply it by the length of the solid. Since my people only use functions to model the cross-sections of the circular parts of ships, we must find the volumes of the shape acquired when the cross-sectional area is rotated about an axis. Just like before, we take the area of the face, which is, in this case, a circle, since the radii are being rotated around a central point, and whose area is modeled by pi r squared. And we multiply it by the change in x, or the length, in order to get a volume. If we do this with multiple subintervals, we create a series of disks, whose volumes can be added together to approximate that of the rotated solid. If the number of disks increases indefinitely and the lengths of the subintervals reach almost zero, then we can model the summation of the disk with the Leibniz notation of the integral times r squared dx times pi. dx represents the infinitely small changes in x, and this whole equation can be interpreted as pi times the integral of f of x squared dx. F of x represents the radius, because it describes in each calculation the variety of x or y lengths. Okay, now let's put this to use. The cross-section of the engine is modeled by the equation y equals square root of x. The volume is found by rotating the area under the curve from x equals 1 to x equals 4 around the x-axis. In order to do that, we must figure out the radius of each disk at every subinterval, which in this case is modeled by y equals the square root of x. Then we take the integral of the square root of x squared from 1 to 4 and multiply by pi. If we do the calculations by hand, we come up with the answer 8 pi. To find the volume of the passenger's cabin, whose cross-section is modeled by the equation x squared minus 4x plus 5 from x equals 1 to x equals 4, we take the integral of the equation squared times pi. Before solving the integral, we write out the square of the equation. Then we solve the rest of the integral by hand. Now for the spaceship base. This is modeled by the two equations y equals cube root of x and y equals x over 4, except this time rotated about the y-axis. Pay attention. Now we must put the length of the radius in terms of the y-intervals by making the equations in terms of x. We do this by isolating x on one side for both equations. Once this is done, we find the intersection points in terms of y and take the integral of the first disk squared minus the second disk squared with respect to y, all times pi, and solve. If the calculations get too complicated, putting them in a calculator and solving the integral is also an acceptable option. Lastly, we find the volume of the transmission station. This volume has an inner radius modeled by y equals negative x and an outer radius modeled by y equals x squared plus 2x. This time, the solid is rotated about the line y equals 4. Thus, when we take the integrals, we need to add 4 to each equation to account for the change in the radius. With these new equations, we follow the same steps as before, taking the integral of the outer radius squared minus the inner radius squared. Now we've found the volumes of all the parts of my spaceship and can build a new one, right?